Hi everybody, my name is Gabriel and I'm building a 3D engine called Horizon. It's a engine, let me play a quick video here. It's a cross-platform engine meant to be lightweight and high performance. It works on the web natively and on mobile and Windows and macOS. It doesn't work on Android and Linux, not just yet. And all those things that you're seeing here are built with the engine. Some of them are actually built by other people. This is an example of a ML stack for taking training data from unstructured video. The engine is the application layer used for capturing the data and running it. So I think I basically want to spend time showing code to you guys here. I think the only thing I want to go over first is just one small thing about how I think about this. Since it's 15 minutes, I'll have to go fast. But if you imagine, a line between, a framework like Raylib, Love2D, the small lightweight frameworks that you can build on top, they are usually super nice to use. They're very flexible. They compile really fast, but they don't always give you a lot out of the box. They're usually a cross-platform renderer, maybe with some plugins around. And if you think about the flagship engines like Unity or Unreal, they give you a lot. There's a reason most games are built with them. They give you a massive asset store. They give you reasonable performance. They're not as customized as other code. But they also take a lot away. And basically, they give you a lot of bloat. Less flexibility, and sometimes they're not even cross-platform in the sense that technically they support the platform, but when you try to run like even a reasonable game on that platform, it basically doesn't run. So I mainly started building this engine because it was the tool that I wanted to use for my main job. Ended up becoming another thing after that. But my idea was, first I want to compile really fast. I want to iterate in code all the time. I want it to be lightweight. I want only to pay for what I use. So I think a couple of principles that I keep in mind as I'm writing it is not tying the engine to an editor. I think it makes a lot of sense. Editors make a lot of sense for artists, and I think you should have one still. But if you try to make a software so someone else can use it to build another software, it's actually a very hard problem to solve, and you end up adding a lot of bloat. Do not take flow control away from the user. Maybe this will make sense for someone who here made a game before, like in Unity or Unreal. Okay, around half. Usually on these engines you have like either a base class that you inherit from, and for like updating the game you have like an update function, a start function, and it looks pretty nice on paper. But the thing is, when you're making a complex application, the thing that you always end up needing is, hey, I need this thing to run after this thing, but not before that other thing. And then the fourth thing appears, and then you kind of want to stick it in the middle. And this architecture is just awful for that, to the point that there are many, many workarounds, including having one single entity with the update function, just so you can dispatch everything from there. You're basically like taking the feature away. Third, a layered API. This will be clear on the demos, but I think in order for the engine to be flexible, you want the low level and the high level API available. You want to be able to start with the high level if you want to get things done quickly, but you want to be able to strip that away to have more control if you need to. And performance as top priority. What this means to me is that I kind of obsess over it, at least to some level. I don't think I do any hardcore performance, but I worry about it. I profile every time and all the time and on all platforms. Okay, so without further ado, let's share some code. So I definitely, maybe I'll try to show too much, so I definitely have code to copy and paste. There's no way I can type out the code that I'm going to share, but I'll try to go over, the idea is to go over from hello world to something meaningful in this engine, right? So.
Could you increase the size another, like 1 or 2?
Yeah. Okay. Sorry for the compiler here. It's an LSP thing. Cool. Let's go ahead and run this. This is the only demo that is not graphical to show the API. So this is basically a hello world in the engine. There are 4 functions, but the two that matter here are app init, app update, and render, which anybody that saw Handmade Hero is familiar with, same idea, platform starts, give you control as fast as possible. There's a reason that I didn't go with like a main function and then you control the loop that I can go into later, but that's basically it. And one thing that you might be noticing, especially if I run the code, is that we got hello world on multiple threads. And because of that, I already have someone to thank here, someone who is not here and someone who is, which is Ryan Fleury and Casey Muratori, because last year Ryan released a article called Multicore by Default, which I read and immediately inspired me. I really, really wanted this engine to be multi-threaded on the user space. But I was almost giving up on that because I couldn't think of any idea better than a job system. The other ideas were a little too out there, and this one was the first that, yes, there are caveats, for sure, but it's doable. And I've been exploring this for the past months, and I probably wrote more multi-threaded code in the past 6 months than in my entire lifetime. Cool. I think going over the code here is hopefully is straightforward for now. You have a thread context on each thread, and here I'm just printfing things. Let me go ahead and let's draw something, because this is an engine. Small example here. This is the low-level graphics API. So if you haven't done graphics, that's fine. Don't worry about it. That's mainly, basically what we're doing here is very low level, definitely not easier to use, super easy to use yet, but you have control. What you have here is a cross-platform GPU layer, everything GPU underlying. You can use to draw graphics on Mac, on Windows, on the browser. So there are two things here worth noticing. One is of course, the cross-platform layer, but probably the most important thing or the most helpful thing is things like that. So this shader cube vertex is not a type that is defined here anywhere. It is generated here. And it's generated from the shader code. And for anybody that wrote shaders in the past, it's like doing your taxes. There is a right way to do it. We're not going to tell you, but you better do it right, otherwise you're going to get a black screen or a crash. And it was by far like the most annoying thing for me, by far, to the point that when I not only wanted the reflection, but I wanted to go as deep as possible, so everything was type checked. So I generate the type for the vertex, the type for the uniform buffer, the type for the pipeline for creating the shader. So everything basically, if I change something on the shader, I immediately get a compile error. Sorry if I'm going too fast. I'm trying to show a lot of stuff, so I'll probably move to the other demo here. Cool. So these are cubes again, and if I really quickly just go back to the other demo, I should have walked you guys through that. On the app init, we basically allocate the buffers for vertex and indices and create the pipeline, right? And this is all generated. And then here we're just setting the transforms for the cubes and then running the pass. The GPU layer is not multi-threaded yet. I'm not sure if it's worth it, to be honest. We'll have to see. But this is like the low level. And what you see actually in this demo here is one level above, which is using a renderer. So the engine has a forward-ish renderer that has all basic features like PBR, shadows, lights, and so on, terrain and grass. Not complete yet, but to give a sense on how the code gets smaller, for instance here, I don't set up any pipelines, I just create the renderer. I just upload the mesh. It's called submesh mostly because this is a separation that exists for actual models. And one thing to notice here is that the renderer API is retained. So when I create the submesh here, and I create an instance, they're basically always going to be rendered, which is a little not so nice to use. Here, I'm just updating the position, so we have this function for that. But it was a little bit faster. So basically, the immediate option would be something like renderer draw submesh, where you have to call this every frame, and it's not retained. Even if I cache a lot of stuff, it would still be a little bit slower on some platforms, so I ended up going with retained. But that's basically what you have. So to try and give a sense of the code, what you need to do is basically create any mesh here and update here. Cool. Let's keep going. We're going to graduate from cubes real soon. Now, basically. Okay, so again, the idea is as you need more stuff, you bring on more stuff, right? So if you need to load a file, you can just call the operating system to load the file. But you can also, it's very common for our engine to have an asset system. An asset system is something that's usually really important, and the main goal for it is to load assets asynchronously, fast, in usually a compact binary format, handle dependencies, and so on. So for the engine, that's this guy here. Here, this thing here is basically a pointer, but that you can check if it's invalid, so you don't get any use after free errors. To load an asset, you basically do this. You pass a path. And then what is happening here? Of course, it's loading asynchronously, but it's also this is kind of fake. It's actually not loading a GLB and parsing it at runtime. This asset system also assumes a duality between a source asset and a cooked asset. So for instance, this asset that I'm loading, right, is here, is a GLB. If let's see how big it is. So 700K. And when you run the engine all the time, it cooks the asset into a packed binary format to this folder here. So basically, there you have it. That's the model that we actually load. And the reason the path is not what you see here is because the idea is that soon the engine will be cooking that on the fly during development. This is not enabled yet because I'm still figuring out how to make this work on WASM. This is the asset format. Everything's going to be suffixed with Bob asset. The main thing that it does is this thing, when you load the file, the data that you see here is the data. There's no parsing involved at all. So if you were to load a file, that binary file with this type, you can just cache the type and it works. All the pointers are self-referencing pointers, self-referencing offsets. So that's why all this abstraction is here, and that's basically what the asset system is loading. So if you go back, I load here, I get a handle immediately to the thing that I just asked to load, and here I can check if it's ready, and if it is, I can instantiate the model, upload the model, instantiate the model, and then I have it. So basically as simple as drawing a cube. And then if we keep going from there, we can start doing some cool stuff. So this is the same demo again, but with some comment and code to enable. So for instance, if I want to load UI, I can just create the UI system. Pretty much the same pattern. You want a new system on the engine, you call create, you call an update, and it basically works. And the system manages its own memory. For UI, which, by the way, uses Clay. Thank you, Nick. The UI is main thread only, so here's the thing that I do for every engine, every project all the time, is this perfect stats. So as soon as I do this, the compiler should fix itself. And now we have a nice profile thing. And one thing that the engine that I haven't touched much is it's all allocators everywhere. There's no malloc anywhere. everything, almost everything. The GPU layer, I let the DirectX manage the buffers for now. I'll go back and fix that. But other than that, all the memory is inside the application layer. If we keep going, we can start playing to make this look nicer. So we can just add the directional lights. Again, all code. For now, we don't have an editor. We don't have a scene or anything. I'll set the light. I'll set the fog. This will probably just work. That doesn't look that good. Let's. OK. This is my 15 minutes. Let me. So basically what I'm doing here is just adding a ground and a skybox and the grass. OK, looks better. Yeah, thanks. I don't want to take time from anybody else, so I'm happy to wrap up here. But for anybody interested in seeing the demos, the nice thing, the last layer in the engine is actually the entity layer. Actually, when I started the engine, my plan was to stop here. To me, this API, I don't think this API is like ready yet, but it is reasonable. Like you have a system that does something meaningful. You create, you update. The system provides you an API that you can use. You can set up your entity system on top of that, and it's fine. However, after talking with potential clients and also like giving more thought, it's clear that an entity system is pretty useful. So had a lot of thought on that and so on. So maybe I'll, basically what I was going to show is that you can do all that with the entity system and loading a scene, and it's a lot less code. So let me jump to the final one, and we wrap up here. Okay. So it's just playing animation. Let me see if I can enable the editor. Okay, so we have an editor here. Hope it's not going to crash. One time it crashed. So there you go. This is really just an extension of all the things that we've been seeing. So this is way less lines of code, and you kind of have the same idea for entities here, and you can just load the scene, and it just works. For anyone interested in the scene itself, it's all text, all readable, but again, it gets converted to binary when you load it. So the idea is I can even edit this by hand, and I do that a lot. Right? Thanks, guys.
All right, we have a mic for Q&A now. Let me know who to pass the mic to for a question.
Hey, I must have missed Ryan's cool article about multi-core by default. Can you explain the multi-threaded model?
Yeah, for sure. Let me go to even the first one real quick, because I think the hello world is probably very simple. Basically, afterwards, I learned that there's a name for this. It's called single program multiple data. The idea is that when you start up, you immediately start all the threads that you need, and they are in lockstep with each other. So you're always running the same program. And the way you share work is, for instance, using a primitive like this. So basically, again, you think lockstep, right? All the threads are here. You can separate the work homogeneously using that, and then the loop that you get is one per thread. And the nice thing about this is that the threads on this specific case never race against each other because the data is separate. Of course, the hard case is when maybe I want to do like, okay, I do this, and then I want to do, basically what is here. Oh, if I'm on this thread, then I do this, right? And then you have to sync. And if you repeat this model again and again, you're going to be adding a lot of syncs, and this will make things slow. And DCS solves for that. You basically do a job system again, but the nice thing is that you do, it's in line. So this MCRQ is the job system is-ish. And the nice thing about it is that it's all inline. One here. Like this is how simple the loop is to, that's basically running a task system. On the top there, we're basically separating all the levels of dependencies and then running all dependencies here.
We have time for one more question.
Yeah, I was just kind of interested. You said like someone was using your library for like ML stuff. I'm just kind of curious what it's like having other people use your engine, and like if you're interested in expanding that in the future and like expanding your audience on your users.
Oh, for sure. It is interesting having people using the engine. Everybody's different, so this is like the best client in the world because he's very technical and he doesn't need me for anything. So literally, he like, I even asked him, hey, do you want any help here? He was like, no, that's fine. So that's great. I have another client that is the opposite, that I work with them. I literally spend hours weekly with them, and that's the most common client, especially for new technology like this. There is a learning curve. In terms of interest, that's actually the point of the engine. I am building it to, it's still in progress, and I want to be something new still. So this version is highly experimental still, but the goal is to have more and more people using, and I'll probably be opening a closed beta soon. So yeah, if anybody's interested and you like trying out making games, definitely tell me, and I'm happy to give you access.
All right. Thank you very much.
Thanks, guys.